truth function for NAND NOR operators. Okay, so we have P, and we have Q, and we have true, 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 false, false, true, false, false. Okay, so we have our NAND operator, and actually before I get into that, let me explain this just briefly. The only reason I'm going to do this is because you do need to have some type of understanding of what's going on. Remember earlier I said sort of what we're attempting to do, but no one's really saying it. Some people are saying it. I haven't really said it, but what we're really attempting to do is reproduce the cognitive abilities that human beings sort of have as a consequence of our development, of our exposure to life within artificial intelligence, right? We want to say that, you know, non-biological matter has the same capacity for knowledge and understanding and learning that we do. That's not easy, right? There's books written on the difficulties of common sense in artificial intelligence, right? It's common sense we think is common, it's not so common trying to reproduce it. In order to make this whole system more efficient, what logicians are always attempting to do is they're trying to consolidate and maximize the level of efficiency within the logic. Now, you have operators like the biconditional, you have operators like the conjunction, you have operators like the conditional. All of these operators can be consolidated, right? All of these operators can be consolidated in the negation and the disjunct, right? And I might actually, that reminds me, I'm not going to go through it now, but I might just put up, type up a little thing and put it up there so you can see how you can use the disjunct and the negation to replace all of those symbols, right? All of these symbols can be replaced with these two, right? So the fact that all of those symbols can be the fact that all of those symbols can be replaced with the negation and the disjunct lets people to believe, well, would it be possible for us to consolidate, right, all of the symbols to one symbol? And this is where sort of the discussion of NAND NOR operators begin, right? It's within sort of the historical discourse on logic. NAND NOR operators sort of arise. They arise out of the attempt to consolidate all of our connectors between our different component parts within a statement and make it more efficient, right? So that's where that comes out. My particular discussion, this particular lecture, takes it even further than that by attempting to consolidate how we begin our formal proofs of validity within both symbolic and predicate logic. So I just wanted to say that as an aside. So NAND NOR operators come out of the history, out of an attempt among many logicians to consolidate our operators to just a seminal operator. Our NAND operator is represented by the slash, or NOR operator, and that's N-A-N-D. Our NOR operator is represented by a down arrow. And then the rest is pretty simple, right? As with the case with any truth table, you just memorize the truth table. There's formal proofs of validity for this, but I'm not going to get into that now. But you just, at this level, just memorize the truth tables. So we have for NAND, false, true, true is false. Right? True, true is false. True, false is true. False, true is also true. And then false, false is true. So the only time the NAND operator is false is when both claims are true, right? When it's true, true, it becomes false. And that makes sense, right? There needs to be sort of the way I like to say it, the ghetto way of thinking of it. If we're talking about a NAND operator, there needs to be some level of falsity in it, right? There needs to be some level of falsity. I'm not going to get into the proof of it, just memorize it. It's only false when both are true. When P and Q are true, your NAND is false. That's simple. All right. It's just the opposite. It's sort of the inverse for the NOR. It's not sort of the inverse, it's exactly the opposite for your NOR operator, which is represented by this down arrow. All right. For your NOR operator, what we have is all of this is false, and it's only when both are false that it is true, right? So for our NOR operator, For a NOR operator, true true is false, true false is false, false true is false, false false is true. Right? So NAND, NOR, just sort of commit it to memory. Now I wanna switch for a second, and it's gonna seem like these things aren't sort of connected, and I'm deliberately doing it that way. Okay, he just talked about this and he's switching to something else. I'm deliberately doing this way, and then I'm going to reconcile and consolidate all of the information as the video progresses. So this is sort of our information on NAND NOR operators.